So gears, immensely useful things. I mean, they're able to transmit power and they're able to change the relationship of speed to torque. So you find them, of course, absolutely everywhere. And people tell me they have a bit of a problem understanding gear ratios. To be honest, it's not that difficult. Here we've got two gears, and for argument's sake, let's say they're the same size. If I put them together and I give that one full turn, that will turn one full turn. Why? They're the same size. If they're the same size, then the two edges meet and the travel distance is the same, and so they must travel the same distance, and one full turn must equal one full turn, because the distances they travel are the same. Of course, you can expand on that, and that one is actually 2.5 times the size of that one. So if I put this back in place, if I can, there we go, and I turn this one full turn, this one will turn the same distance around the circumference. So this will turn part of a turn. Now this is 2.5 times bigger than this. So if I turn this one full turn, this must travel 2.5 times as far because of the distance around the circumferences. And that is the basis of gear ratios. If the gears have the same circumference, the ratio is 1 to 1. One turn equals one turn. If the circumference is 2.5 times, let's say 2 times for convenience, twice as big as this, one full turn of this will turn that 2 times. One turn of this will equally turn that half. Or if you like, we'll need 2 turns of this to turn that once. Now, it's not the actual circumference of the circle, it's the circumference of the imaginary circle called the pitch diameter, because the teeth jut up into the gear a little bit and jut down into the other gear a little bit, and there's a point at which they meet, and that's the pitch circle. So as long as we can remember that it's just the distance that we're talking about, gear ratios become pretty trivial, really, because if that's twice as big as that, the ratio is twice as big, because the effect it has is it doubles the speed and halves the torque, or doubles the torque and halves the speed, because it's done in the same 2-to-1 relationship as it must be. This is all just straightforward mathematics that I contend isn't that complicated, but it is really interesting. Now, gears, of course, have teeth on them, so what we do is we take a shorthand and we say it's the number of teeth, because the number of teeth is related to the pitch circle. So if this has 10 teeth and this has 20 teeth, there are 2 times as many teeth, and because there are 2 times, it's a 2-to-1 ratio. It also depends on which one is driving and which one is being driven. So if this is driving, it's 2, and this is driven, it's 1. So the drive to driven ratio is 2-to-1. Equally, if this one is driving, this is being driven, and the drive to driven ratio is 1-to-1/2. And so we can quickly get hold of what gear ratios mean. Now, for a very, very long time, that was held to be absolutely true. If you had 2 gears with the same number of teeth, you would get a 1-to-1 ratio. But that actually isn't strictly true. You can get gears to change reduction ratio even if they're the same size. So I do this up in Tinkercad, and it will do what was thought of for, well, decades, if not centuries, as absolutely impossible. We can get a gear reduction from this even though the 2 gears are absolutely the same size. So let's print that off and put that together. Right, let's put this together. The first bit is this tiny peg and this, and it goes in that way around, and it should be a tight fit, so drive it in. When that's done, take this one and it goes on there with a little bit of glue, because that shouldn't be able to turn in relation to that. Now we take these arms and then just clip onto there, and they should be free to swing. Like that. We take the stand and this gear, and it goes in through there and should be free to turn. The next thing to do is take one of these clips and put it on there like that, and then the handle goes on there like that, so we can turn that whole thing. Then we take the longer peg and drive it in there, and again it should be a tight fit. Long peg then feeds through there like that, and then we put a clip on the back of it. So when that's on, you lower that into position above there, and then that will line up with that hole there like that. And we put that peg through the first one where it should be free to turn, and through the second one where it'll be a tight fit. When we've done that, it gets its final clip over that one there. So that's it completed. Right, we've put a dot on there and we'll use the handle as a registration on there. So when we turn that handle one full turn, something curious will happen. So we've turned it one full turn. That has only turned half a turn. So what we've got here is a ratio of 2 to 1. And even though we're using gears of exactly the same size, we've got a reduction ratio because of this. So that I thought was an interesting mechanism because it does something that was thought impossible. Here we have two gears of the same size where it should be a 1-to-1 output, and it isn't. This is in half because of this bar, of course, but we have two gears of the same size in direct contact, changing the ratio that was always thought to be 1-to-1. I think that's really quite interesting, even though that mechanism is surprisingly simple. Now, the quick amongst you will have also noticed it's done something else. This ratio has been transmitted on this axle and this axle. So it's actually halved the output on two axles. It's split the power without having to do anything else. I thought that was just fascinating. Now, I will put these files on Thingiverse should somebody want to play with this, because I think it could be a pretty useful little mechanism to have in your armory. So, of course, I'll put it onto Thingiverse, and, of course, the link will be in the description below. But I hope you enjoyed it, and I hope you found it as interesting as me. Thank you very much for watching, and please do remember to like and subscribe.